Hello everyone, this is Chandana Mulpuri. I'm working with IBM as a senior security specialist, and I'm very glad to present today here in Neo4j. So we are today talking about graph-powered compliance and how we can build intelligent regulatory mapping with AI and Neo4j. So let's get started. Nowadays, the compliance in cloud is kind of where we are using multi-cloud tenants and we are having a lot of crisis, which is why traditional approaches are failing because of the different requirements in the infrastructure. So the solution for this we've come up is cloud environments span and destroy resources in minutes. So yet most enterprises still rely on them. So what we are doing in our current environment is we are doing annual audit cycles where we were doing annual audit cycles where it was too slow for dynamic cloud infrastructure where we were using multi-cloud tenants. And we were also doing manual documentation where the resource intensive, we have to use a lot of resources and we have to have a lot of team members working on manual documentation whenever it is necessary. And this also is prone to errors. And whenever a team member leaves or whenever we had to do some knowledge transfers, it was very difficult for us and it was always stale. So, coming to the reactive posture, compliance gaps are discovered after the fact whenever we are going through the audit or whenever we have some risk that is brought to us. So this is the current gap we were facing, and the core problem in the current industry is where we are using dynamic resources, where the workloads that live only minutes and not months. So because whenever there, let's just say we have a current a market. Production environment that's going live, or we have hit a number of users in a particular uh, off a period. So the workload is only for a couple of hours or a couple of minutes, and then it goes down, and it is not for staying forever. So the regulatory complexity is the next one, where multiple overlapping frameworks like SOC 2, NIST, ISO, FedRAMP, and GDPR come into place. And the multi-cloud sprawl, so where controls scatter across AWS, Azure, Google Cloud, IBM Cloud, etc. So the because of this, we have an alert fatigue. So we have set up alerts for a lot of things, and large volume of alerts used to come up to us, and the volume of signals, which is overwhelming to the security teams, and we don't know which is the critical alert and which can be even though we have SEV 1, SEV 2, SEV 3s, because of the volume of the SEV 1s or SEV 2s, we don't know which is the most critical one because of the alert fatigue. So in this topic, in this presentation, what we'll cover is why graph for compliance, why the shift from tables to relationships, why graph schema design works, modeling contracts, regulations, assets, and evidences work. AI on the graph, how ML traversal, anomaly detection, and requirement extraction are done, and OSCAL integration, standardization formats, enabling framework interoperability, which helps. OSCAL is one of our major development, and CI/CD with multi-cloud, compliance as a code in real pipelines more than compliance as a service. And what we can also talk about is the AI governance, data sovereignty, and emerging frameworks. So let's head right into the topics. So why Graph for compliance works? Right now, Graph is fundamentally a relationship problem. A control doesn't exist in isolation. It maps to the regulation. So where the regulations play an important role and applies to assets and is validated by evidences, which also relates to other controls and which is why the relation database models this acts as a rows and joins like database models. So graph database models it as actually as it concerns the network of dependencies where we can do graph databases. So this is the graph schema for regulatory mapping, where in the first circle, we have regulation, which defines the requirements that maps the controls. The second circle, we have controls, where we implement rules and link them to the assets. And the third set is assets, where we host our resources tied to the controls and evidences. And the fourth set is evidences, where we prove the control status for gaps and analysis. Designing the schema this way correctly is foundational. Each node type carries metadata framework version, the risk weight, cloud provider, evidence stamp, timestamp, and while relationships carry the most important, the compliance logic that makes the traversal meaningful. What Neo4j brings to the table here for us is the native graph storage, where relationships are first established and the first class citizens know where the mismatch between data model and queries is not no more an impedance, and cipher query language where expressive, readable traversal across deep regulatory hierarchies comes in picture. And the third one is graph data science library, where built-in machine learning algorithms for ML pattern detection across compliance networks happens, and this brings a lot onto the table. So let's talk about AI on the compliance graph. There are three AI capabilities that I want to talk about here. The requirement extraction, where the machine learning algorithms traverse regulatory knowledge graphs to extract structured requirements from unstructured documentation mapping to machine readable controls. And anomaly detection is where the graph-based pattern recognition identifies the potential control failures by analyzing the deviation patterns across connected compliance networks. And the third is the risk prioritization, where graph centrality algorithms surface the highest impact gaps, reducing the alert fatigue, focusing the teams on controls which with the most important priority regulatory dependencies. OSCAL. Let's talk about OSCAL. The interoperability bridge here, which is OSCAL is nothing but the open source security control assessment language, which we call as OSCAL here, which provides a standardized machine readable format for representing security controls and assessments. When OSCAL is integrated with Neo4j, OSCAL catalogs the map directly to graph node schemas. Profile overlays become relationship attributes, and assessment results feed directly into the evidence layer. Multiple frameworks like NIST, FedRAM, ISO become interoperable nodes in the same graph, which is a great asset to the team. So compliance as a code in the CI/CD. This is another interesting topic we have. Rather than compliance coming at the end of the development life cycle, after everything is done and we are ready for production, we've integrated compliance as a code in the CI/CD pipelines itself, where whenever the code commit happens, it triggers the CI/CD pipeline, and the control validation happens next in the next stage of the pipeline, where we run rules from Neo4j graph. And the third stage would be the policy query, where we detect violations via graph queries. And the fourth stage in the CI/CD would be enforced remediation, where we automate the fix or block the deployment automatically in this via the CI/CD pipelines. So, control validation here requires requirements encoded within the graph structures are automatically triggered within the CI/CD pipelines, which is shifting compliance left and catching gaps even before the resources are provisioned and not after. So, coming to the multi-cloud compliance coverage, where a single graph for every cloud. This helps the leadership, the teams, as well as anyone understand better about the compliance across the whole environment. So, graph architecture provides a unified compliance layer across heterogeneous infrastructure. So, each cloud provider's resources become nodes, and compliance relationships span them transparently. So if you see AWS, guard duty, config, security hub, and if you consider Azure, it's Defender, Policy, and Sentinel. And if you consider GCP, it's SEC, Chronicle, and Policy Controller. So all of them become as a unified compliance layer across the infrastructure, and we have a single unified graph for all the multi-cloud environments. So, managing the alert fatigue with graph prioritization. This has been a major help for the team because previously we used to have a lot of alerts coming in from different cloud environments where the team was very overworking on these alerts where it is not very necessary on some of the alerts where even though we configured minimalistically, we had a lot of alerts popping in because of the multi-cloud environments. So how we manage the alert fatigue with graph prioritization is we enable graph centrally, where controls in the most downstream dependencies are ranked highest. Fixing one node resolves many of the findings. And the second thing we did was establishing relationship weighting. So we risk scores for where the risk scores follow through edges regulatory impact, which propagates across the graph automatically. And the third one we have enabled is a context-aware triage, where alerts carry full graph context with which regulation, which asset, which evidence is missing, so that we have the maximum amount of information the team needs to have to be able to fix and apply the patch. So, considering the road ahead, emerging compliance frontiers, AI governance, let's talk about this. So, EU AI Act and emerging AI regulations require traceability between model behaviors and regulatory obligations as a natural fit for graph modeling. If we talk about data sovereignty, cross-border data flow restrictions model as graph relationships enable real-time sovereignty violation detection across cloud regions. Continuous assurance. Enabling this gives us continuous assurance because as frameworks multiply, graph-powered compliance scales without rebuilding new frameworks, become new models, not new systems, which helps the systems, which helps not creating the duplicate systems. So here we've spoken about compliance a lot. So the key takeaways of the session would be like compliance is a graph problem where relationships between controls, regulations, assets, and evidence are the core compliance model are the core of the compliance model them natively. So AI amplifies the graph, where machine learning traversal, anomaly detection, and risk prioritization become powerful when applied to connected compliance data. The shift left with compliance as a code, which embedded control validation into the CI/CD pipelines to catch gaps before deployment, not after the audits. And OSCAL, which enables scaling. Standardized formats allow one graph to span multiple frameworks without rebuilding from scratch. Um, Thank you for joining the session. If you have any questions, I'm here to answer.